Yeah. Hello. Online students, just verify that you're able to hear so that I'll begin with the lecture today. Okay, thank you. Okay, so yeah, in the last lecture we have seen some basic definitions of cost, but I want to just point out one thing is that it is production. Okay, if at any point you're not able to hear or I'm not audible properly or any other issue with the presentation, immediately alert me, okay? Otherwise I may miss that, okay? And that can be a problem for you all, okay? So remember, it's always this production and production relations in turn create the various costs, okay? In yesterday's lecture, okay, we have defined two levels of costs. One is total cost, okay, and we have seen that this total cost can be expressed as a sum of, I hope you all remember this, TFC and TVC. Okay. Similarly, we saw another cost concept which is per unit cost. Okay. Per unit cost. And for the per unit cost, we have again seen that we have average fixed cost and the average variable cost. We have average fixed cost and the average variable cost. The sum of these two costs give us what is called as the AC, or some books also write it as average total cost, okay, ATC, okay. Now this all theory that we have been doing, we will very soon see is what is called as the short run cost theory. It is called the cost run. It is called the short run cost theory, and in today's lecture we'll see what is the difference between short run and the long run. Okay, so given the cost concepts that we have, okay, I want to draw your attention. To, and also there is some agenda that I have not done, which also we want to define. We want to define a very important concept called marginal cost, okay? And we'll see that this marginal cost in turn has a great influence on all these costs, okay? So we are doing this topic step by step, okay? But ensure that you try to keep this picture in mind, okay? Now, let us first write in economics what we mean by, what we mean by a firm, okay? So, in the last lecture I told you firm is any organization which is producing goods and services with a commercial motive, okay? That commercial motive is a very important idea, okay? So, and we have seen that the firm's goal is to maximize profit, okay? And you all know profit is simply the difference between total revenue and total cost. So right now we are looking at, from the last lecture we have been looking at the total cost, To just get familiarized, we have defined some major cost functions: the average fixed cost, average variable cost, average cost, okay? But now we go one step back. We look at a firm and we see how production laws, okay, what you have to understand now is how production laws determine how the production laws determine cost functions. Okay, so this is what is the agenda for today's lecture, and this is a very important idea, simple but important. Have you got this? Can I proceed? Am I audible? Are you able to follow? Online students? Okay, thanks for the reply. So let us now look at what is the production, and yes, thanks Shivam, and let us write like, okay, so you know, just now we are going to think about a firm in a very simple way. We can think of a set of inputs that go in production of goods and services, like it could be labor, okay, raw material, capital goods. All these are called the inputs, and these inputs help the firm produce what is called as a output. Okay, so we can think of a large company like Tata Motors. Their output may be cars and trucks, and the inputs could be large variety of labor that they employ, steel that they buy, rubber tires that they buy. All these things are the inputs, and what the firm produces is the output. Just keep one thing in mind. The form of output generally is very different from the inputs. Okay, like for example, in a car company, the inputs are steel, iron, rubber, wheels, various spare parts that are used in car, and the output is a car. Okay, so that car is very different from its inputs. Okay, so this kind of thing becomes very critical when we discuss even in law what exactly is production. Okay, so we have a transformation relation. I can write this: output is a function of inputs. Okay, output produced during a period of time is a function of inputs applied during the period of time. Have you all got this? Okay, this period of time means we are talking about per month output, per day output, per week output. So we'll have to talk about the outputs and the inputs during that particular time period. Okay, so can I proceed? Have you understood production? Let us just write this: production function gives the maximum output, for a given set of inputs. Okay, in this word maximum is very important. Okay, that is, production function gives the maximum output for a given set of inputs. Okay, fine. Have you got this idea? Now I will write with a very simple example. I'll write here an example of a production function Q. This is the output per month, per annum, whatever. Let me write per month. And F is the inputs, capital and labor, that are being applied. Maybe capital units hired per month, labor units used per month. So this is a flow relationship. How much is the output produced and how much are the inputs used? Okay, and this F represents what you may call as a production function. Okay, so it is kind of giving you what would be the maximum output for a given set of inputs. Okay, did you have time to write this down? Can I proceed? Okay. Okay. K, the capital K stands for units of capital used. Okay. In production process. Okay. And L stands for units of labor. Okay. Another factor of production sometimes is land. Okay, now land also is starting with L. So many times in the economic textbooks you may have K, L and T. Okay, so K stands for capital units used, L stands for labor and T stands for land. Okay, so this way this would be a set of inputs. Okay, now if you actual real world, just imagine there are thousands of inputs that are used in production process. We cannot write them all. So what we do in analytically is that we lump all produced inputs in one as capital and all human inputs in terms of labor. So we can just work with a very simple model of production by the firm with the help of two inputs, capital and labor. Have you got this? Is this fine? Can I proceed? Okay. Now, imagine a situation like this, you know. This is a production function. And in reality, what happens is that we can think of two types of situations. Okay, what we call as a long run situation. It doesn't refer to any time period, let me tell you. And other is a short run situation. Okay, we can have two kinds of situation. One is the long run and the other is short run. Okay, what we mean by long run is where all inputs can be, now see, I'm going to write in a very simple symbolic language, can be increased or decreased. Okay, the up arrow means you apply more of the inputs, down arrow means you reduce the inputs. So a long run is a situation where all inputs can be increased or decreased. Have you got this? Long run function have you got? Yes, online students, please confirm so that I can proceed. Okay, very good. I would encourage you all to respond quickly. And yeah, one of the reasons why I'm not, I don't want to call out your names is because we are also having an online recording. So I really don't want to call names. Okay. So try to respond whenever I say online students, so I know that it doesn't sound good. You all have very nice names, but okay. Let's look at this. What is a short run? How is it distinguished from the long run? Now, in short run, at least one of the important inputs remains fixed. At least one of the inputs is fixed. That is, it cannot be increased or decreased. You have a fixed amount of input that is there. Okay, so not all inputs are fixed, but at least one important input is remaining fixed. That would be a situation in the short run. And realistically, this is the scenario for all the firms. All the firms, they are always typically operating on the short run, where at least some of the inputs are remaining fixed. Why this is true? Suppose you think like a company like Bajaj Auto. They have a fixed plant size. They have already purchased land and they have constructed a plant earlier in Akurdi, now in Chakan and many other areas. But that plant is fixed now, given. So in that sense, you can think that their land and capital is remaining fixed. And in short run, they can only change the labor input. Did you all get this? Okay, so I'm going to write a way of writing short run production function. If I'm thinking of two inputs, capital and labor, I want to somehow show that one of them is fixed. So I'm putting a horizontal line over K, means capital input. Okay, capital input is fixed. Okay, and there is no horizontal line over L. That means labor is variable input. Labor is the variable input. Have you got this? How to distinguish short run and the long run production function. In the long run, if I'm writing simply like this, f of KL with no horizontal line above them, that means both can vary. Capital can vary as well as labor can vary. So this will be long run production function. Long run production function. And this, where capital remains fixed and labor is the variable, it is called short run production function. Okay. Suppose, I want you to do this, just label. Firm has three inputs, capital, labor, and land. Okay. And let us say it's an agricultural field and the farm size is a fixed variable. Okay. How will you show this in the form of a production function? How will you write this? Q, the output of the farm, is a function of K, capital applied, L is labor input used, and T is the land. How will you show a situation that land is the fixed factor? How will you show the note? How will you write it in the notation? Can you all write that in your notebooks? Can you all write in the notebooks? What is that? How can we show that? Okay. Thank you. Anybody else? Other students? Have you got it? How to show? Correct. And the meaning you have to write and explain that. What does it mean? Suppose I draw a vertical line over T, it means land is fixed. And what are the variable factors? Capital and labor. Okay, and think the other way around. Think the other way around. If this is a Q is equal to F, K, L and T with no markers above these aggregates K, L and T, what it means? All three are the variable inputs. That means this is the long run production function. Okay. Okay. Can I proceed? Have you all got the idea of what is a short run production function and what is a long run production function? Okay, I'll proceed. Now we are going to write two distinct laws which play a very important role in our cost theories and in economics in general. One is, so let me write this production function. Okay, PF stands for production function. Production function we can think of as long run and this as short run. Okay, I want all of you students to think, I'm using so much of notation. I want you all to get used to this notation. It helps a lot when you're preparing for exams to write everything in a shorthand. Okay, that helps you enormously when you're preparing for exams. Okay, so here PF stands for production function, and when I go down on this line like this and to the left, I mean I'm talking about long run production function. When I'm reading production function and SR, that means I'm talking about short run production function. Okay, now there are two laws associated with production function. One is relating to the long run and one is relating to the short run. Okay, this is called, okay, the long run law is called the law of returns to scale. Okay, they are called law of returns to scale, RTS. And short run is called the law of variable proportions. The law of variable proportions, and this is also sometimes called the law of diminishing marginal product. Okay, returns to scale and the law of diminishing marginal product. Okay, fine. So, and later on, just remember what we're going to eventually show, that is long run laws of returns to scale give us the long run cost functions. They will give us the long run cost functions. Okay, and the most important cost functions that we study: short run, law of variable proportions will give us the short run cost functions. Okay. So there is a very strong reason why we study this. Okay. The production determines cost, and production in turn gets determined by variability of inputs. So when all inputs can be changed, we say that the firm is in the long run. And for the long run firm, it is the returns to scale. And for the short run firm, it is the law of variable proportions, or it is also more commonly called as the law of diminishing marginal product. Perfect. Can I proceed to write down the law of returns to scale? Laws of returns to scale. Okay, or I may just write, in future I'm going to just save time by just writing RTS, capital R, capital T and capital S, standing for returns to scale. Notation is clear, everyone? Online students, have got a notation. RTS stands for? Okay, good, very, very good. Okay. Yes, the other students also have got it. Thank you. Thanks. Okay, let's proceed. Okay. Okay, laws of returns to scale. Okay. Now remember here, we think about a simple thought experiment. Okay. If all inputs, if all the inputs, let me write, if all the inputs are doubled, okay, means just think of it like this, a firm is using capital and labor. Suppose we think that a firm is using 5 units of capital and 10 units of labor. Okay, 5 units of capital and 10 units of labor. Then what will happen if you double the inputs? What should be the vector? 10 units of capital and 20 units of labor. Did you get this? If the firm doubles all the inputs, if all the inputs are doubled and the output is doubled and the output is doubled, means input double ho gaya, output also gets doubled. Okay, then we say firm has constant returns to scale. This C stands for constant. Okay, it stands for constant returns to scale. If all inputs are doubled and the output is doubled, if all inputs are doubled and the output is doubled, then we say that the firm has constant returns to scale. Did you get this? Have you all got this? Constant returns to scale. Okay, so this is the first, the baseline case. Okay, double the inputs and output gets doubled. Let's look at the two other possibilities. If all inputs are doubled, okay, if all inputs are doubled and output is more than doubled, म्हणजे दुपटी इनपुट्स डबल किए बट आउटपुट डबल से भी ज्यादा इंक्रीज हो गया, मे बी ट्रिपल से इंक्रीज हो गया, 4 टाइम्स इंक्रीज हो गया, तो देन वी से दैट अ firm has increasing returns to scale. This I stands for increasing returns to scale. Then we say that a firm has increasing returns to scale. So आपको दोनों, you have to memorize, these laws are so important that you cannot afford to just forget them. Okay, let me write the third and the final rule of returns to scale. Write this first part. If all inputs are doubled, and output increases but by less than double. Output increases but by less than double. Okay, then the firm has decreasing returns to scale. The firm has decreasing returns to scale. Okay, so just look at this box. Okay, inputs are tripled. Okay, 3 पट बढ़ा है inputs. Okay, I want you to write output for the firm if it was increasing returns to scale. Choose some number, whatever comes to your mind, which will be consistent with our law. And I want all of you to type in that answer into the text. Okay, अगर inputs हमने triple किए, firm is experiencing increasing returns to scale. तो what number will you choose here? Double के लिए more than double हो गया. Okay, so triple means 3 गुना किया, 3 times. So what will you choose as a number which will be consistent with increasing returns to scale? Choose a number, type into the box, chat box, what number would you choose? Come on, quickly. Yes, very good. I got one number as 4. That's perfectly fine. Because अगर inputs 3 times बढ़ गए and output increases by 4 times, then it's consistent with the firm experiencing increasing returns to scale. Okay, now this is the hint. Tell me what would be the only number which will work for constant returns to scale. 3 गुना इनपुट बढ़ गए तो आउटपुट कितने से बढ़ा तो हमारी we can say कि the firm has constant returns to scale. 3, correct. So this also should be 3. And choose a number for decreasing returns to scale. Yes, any number more than 1, but it should be less than 3. So if you say 2, it's perfectly fine. Have you all got this? Have you all been able to get why these numbers are put 4, 3 and 2? Means अगर inputs triple हो गया, output भी triple हो गया तो ये constant returns to scale की case है. Inputs triple किए पर output दुगना ही बढ़ गया, double हो गया, तो ये decreasing returns to scale है. क्यों? Because inputs 3 गुना बढ़ा but output has increased only by 2 times. And if inputs triple and my output is increasing by 4 times, then we get what is called as the increasing returns to scale. Have you all got this? Is that clear? Okay. The consequence, write down the consequence of this long run law of production. Consequence of long run production function is that the long run cost curve, long run average cost curve, right? Long run average cost curve is U-shaped. Okay, I'm just writing like this. Cost, long run average cost, and I'm writing Q here. What it states is that it's U-shaped, meaning जब पहले production कम रहता है तो generally the firm is experiencing increasing returns to scale. So the average cost is falling. Okay, it is falling when the firm is experiencing increasing returns to scale. जब firm is experiencing constant returns to scale, my average cost also is neither increasing nor decreasing. It will remain flat. It will be a constant returns to scale. And when the firm starts hitting into decreasing returns to scale, the long run average cost is also increasing. Okay, so one thing I have not done, I have not shown the derivation of this because that will take too much time and not required for our purpose. But you have to understand what is giving rise to this long run average cost. It's the U-shaped curve because for the low volumes of output here till then, we are experiencing increasing returns to scale. When the production is at an intermediate range, firm starts experiencing constant returns to scale, and when output is exceeding beyond a point, firm experiences a decreasing returns to scale. Okay, what I'm going to give you is that I'm giving you a 5-minute short break, and immediately we will do the short run production theory. So in my computer the time is showing 3:37. I will begin the teaching again at 3:40 exactly, so that we have around 20-25 minutes to do the short run law of production. Okay, so I'm going on mute. You also take 3-minute break and we'll resume the session. Is that fine? All of you got this, online students? Hello. Okay, fine. I'm going on mute. So exactly in 3 minutes, I will restart the lecture. Hello. Yeah, hello. Can you all hear me? Online students, are you able to hear me? Yes, thank you. So, can we start? Okay, so we have seen in the last half an hour what is the law of constant or returns to scale. You know, there are three types of returns to scale: increasing, constant, and decreasing returns to scale. Okay, you should try to memorize this law. It is sufficiently important, and we have also seen consequences of the long run cost curve. Okay, so let us begin now with the short run production function. Okay, short run production function. Okay, so in the short run production function, at least one of the critical inputs is remaining fixed. That is what the law says. Okay, at least one important input remains fixed. Okay, at least one important input remains fixed. That is our short run production function. Okay, so I'm going to think of a production function like Q, is equal to F of KL. Okay. And I'm going to put a bar over K. What does that mean now? All of you know this. Line over K, now what does it mean? Which is the fixed input and which is the variable input? Yes, fixed input is capital. Okay, I'm not writing the full thing. And variable input? Yes, variable input is labor. Are you with this? Okay, so let's quickly make a hypothetical table. Okay, I'm writing K L and Q. Okay, and I need one more very important column on the right hand side. Okay, done. Have you plotted a column like this, all of you? Okay, now I'm going to think of a situation where capital is remaining fixed. So this is, I'm choosing any constant number, you know, here I'm taking capital is fixed at 10. That's why the number is remaining same. Okay, and let us say labor input is 0 and 1, 2, 3, 4, let's go till 5 and or 6. Okay, 6. All of you got this? Done? Okay. I'm now showing quantity. If there is no labor, my labor output is also, production output is also 0. Okay. And with the first unit of labor, let us say the firm is able to produce 20 units of output. Okay. With application of second unit of labor, let us say the output is going up by 50 units. Okay. And the third unit, when I'm adding, I'm getting an output of around 60 units. Fourth unit, when I add, I'm getting an output of 65, and let us say fifth unit gives me an output of 68 and 69. Okay, these are hypothetical numbers. You can take some other numbers also, no problem. Okay, fine. Have you got a table? Does it make sense? As I'm increasing labor and capital remaining fixed, the output is increasing. Okay, but how fast is the output increasing? For that, in economics, we define a very important concept called marginal product. Okay, please write the definition of marginal product. Marginal product of an input. Marginal product of an input is additional output, is the additional output from producing or from using one more unit of input. One more unit of input. Okay, so marginal product of an input is the additional output from using one more unit of input. Okay, so here we are thinking about marginal product of labor because capital is remaining fixed. Okay, so let's compute this very important concept of marginal product. For the first case we cannot, because there is nothing like a minus labor input. Okay, now when you look at the case at second column, for 1 unit of labor we are producing 20 units of output, and when 0 units of labor we are producing 0 units. So the first unit of labor has contributed 20 minus 0 units of output. What is that? 20, correct, absolutely right. Did you all get this? Logic is clear. 20 minus 0, and this is 1 minus 0, so 1 minus 0 is 1. So additional output produced by the first unit of labor is 20. Okay, I am going to do one more calculation, then I hope you all will do the calculation. When I am using the second input, total output is 50. And with one input of labor, total output is 20. So how much is added by the second labor? Earlier with one labor I was producing 20, with two labor I am producing 50. So what is the marginal product of the second labor unit? 30. Got it, right. Okay, quickly compute. Yeah, very good, that's right, absolutely right. Just do the other steps, fill in the blanks and tell me what is the in the next case. Okay, very good, absolutely right. 60 minus 50. Yes, then after that 5, correct. 65 minus 60. Then what is it? For the fifth unit of labor, it is 68 minus 65, that is 3. And the last one, yes, correct. Yes, very good. Well done. So all of you got this? It's 1 here, okay. So now write down what do we mean by the law of variable proportions, or sometimes even the law of diminishing marginal product. Okay, what it states is that, see, look at, if I were to draw only the marginal product, okay, I'm not drawing anything else, I'm just drawing marginal product. Okay, so let's do this. 0 we cannot calculate. For first unit it was 20. Okay, let me say this is 20. So 20 and 1. For the second unit it was 30, correct? 30. Then for the fourth unit, third unit, it dropped down to 10. So it got here. Then fourth unit it was 5. Then fifth unit it was 3. Then sixth unit it was just 1. So look, if you just try to connect these dots, you know what is happening? The graph can go up, but eventually the graph is going down. This is the law of variable proportions. Okay, so let us write it down. According to the law of variable proportions, according to the law of variable proportions, according to the law of variable proportions, law of variable proportions, invent a short form, law of variable proportions, Okay, when capital is fixed and labor is increased. Labor is increased. Okay, when capital is fixed and labor is increased. Okay, then at some stage, the marginal product of labor. Okay, at some stage, the marginal product of labor will decrease. Or it will start falling. At some stage, the marginal product of labor will decrease. Okay, this is called the law of variable proportions. Did you all get this? Yes? Okay. Done. Have you got this? Can you tell me from where the law of variable proportions, diminishing marginal, okay, write this, since marginal product is falling, since the marginal product is falling, this law is called the law of, it is called the law of diminishing marginal product. It is also called the law of diminishing marginal product. Have you all got this? Online students, have you got the law of diminishing marginal product? Okay, great, thank you. Just let's summarize this law in terms of behavior of marginal product. Okay, so write stages of law of variable proportions. Okay, all of you pay attention, because this is the last thing we are doing for today's lecture. Okay, so we are now trying to write the stages of the law of variable proportions. Okay, all right. See, when marginal, okay, I'll write stage 1. Okay, stage 1, marginal product is increasing. Marginal product is increasing. Okay, okay, and this is sometimes called the increasing zone. It is called the increasing zone. Okay, it's called the increasing zone. Okay, why is it called increasing zone? Because the marginal product is increasing. Okay, then we have what is called as stage 2. Okay, where marginal product is positive is positive but diminishing or decreasing. It is positive but it is decreasing. It's positive but it is decreasing. Okay, so this stage 2 is generally what we call as the stage of decreasing marginal product, and it is also called a rational zone because most of the firms will operate in this region. Okay, and stage 3 the stage 3 is marginal product is negative. Marginal product becomes negative, and when marginal product becomes negative, no firm will ever operate here because you are hiring more inputs and your output is decreasing. So this zone is called the irrational zone because no firm will ever operate here. It is called the irrational zone. Okay, and since this is where the firms actually operate, where marginal product is positive but diminishing, that is why we call this zone as the rational zone. Okay, so the three terms: increasing zone means where marginal product is increasing. Rational zone means marginal product is positive but it is diminishing. And stage 3 marginal product is negative, that is, it is also called the irrational zone. Okay, so that completes our law of variable proportions, and I will just draw once more the diagram of marginal product and total product, and then we will stop. Okay, for this lecture. You can wait for your next lecture. Suppose I have input L here, and this is the marginal product of labor. Okay, and just below this, draw the total product and labor input. Okay, so once you do this, draw in a very specific way like I am drawing. Suppose marginal product is going up initially and it is falling and becoming negative. Okay, so I am calling this region, okay, this region where marginal product is at its maximum. This is stage 1, or sometimes it is also called the zone of increasing returns. Okay, and look here, till this point, so let me call this as L1 and L2. Between L1 and L2, marginal product is positive but it is falling. Okay, so this region is called stage 2 or the rational zone. This is increasing zone. This is the rational zone. And जहाँ पे ये क्रॉस करके नेगेटिव जा रहा है, ये कर्व नेगेटिव में जा रहा है, that means marginal product is decreasing. That is your irrational zone. Okay, that's stage 3 or the irrational zone. Okay, and corresponding to this, let us draw the production function. So I'll mark this as L1, this point as L2. Okay, all of you do the same thing. Draw marginal product and this curve one below the other. Okay, so once you do this, you'll have to mark this point on L1. Till this point, marginal product is increasing. So I mark a point like this, and what happens? Our production function is starting at 0, it goes on increasing till it hits this point L1. After L1 to L2, production is increasing but at a decreasing rate. Okay, so let me use another colored pen. Let me use a dark green. Okay, so between this to L2, it is increasing but at a decreasing rate, and when it goes into zone 3, that is the irrational zone, what happens? This output starts falling. It becomes negative. Okay, it becomes negative. So just remember one thing, this is a question that can come in multiple choice questions many times, so you have to know these diagrams well. But also remember one thing, when marginal product is 0, the total product is at maximum. Okay, the maximum point of production is when marginal product becomes 0. Okay, fine. All of you just write one last thing. Write just one last thing. The law of diminishing marginal product. The law of diminishing marginal product. Law of diminishing marginal product gives us the short run cost functions. The law of diminishing marginal product and its behavior is what gives us the short run cost concepts. Have you all got this? Okay. So now, since you are going to have another lecture, I wouldn't have enough time to sit and start with the derivation of showing how law of diminishing marginal product determines short run cost. So ये important topic है. हम वो next lecture में we will finish this particular case. Okay, so have you all got this? Have you understood? We have done the two laws of production. One relating to the long run production function, which is called returns to scale, and the other law which we have done is called the law of diminishing marginal product, or the law of variable proportions. Okay, so yeah, with this I will stop.